Chapter 5 introduces one of, if not the most fundamental concept in finance, time value of money. This is such an important topic that the chapter is divided into 3 parts. In Part A, we'll cover the basics of time value of money. In Part B, we'll cover annuities, and in Part C, we'll expand into related topics of rates of return and amortization. Time value of money problems are quantitative, and they can be solved in several ways. But first, we have to understand the definitions. We'll look at the formulas as well as solving TVM problems with a financial calculator and in Excel. Present value is the value at time 0, today. When looking at a stream of cash flows over time, present value is the current value discounted at an appropriate rate. Future value is a more intuitively comfortable concept. This relates to the value at some point in the future of an investment made today. Under various circumstances, the interest rate can be called the discount rate, the cost of capital, the opportunity cost of capital, the required return. We'll use these terms as we move through the topics in this class, and we'll understand the different usages. Drawing a timeline to understand when cash flows occur can be helpful, especially when the setup is complicated. On a timeline, the tick marks the end of the period, so the 1 marks the end of period 1. The default in finance is that cash flows occur at the end of a period. Time 0 is now, today. When representing cash flows on a timeline, we observe some rules. If the cash flow is coming into you, it's positive. Out from you is negative. A loan is income to you, so it's positive, but the loan payment is an outflow, negative. Depositing money in a savings account is an outflow from you, so it's negative. The abbreviation CF implies that the cash flows in different periods are not the same dollar value. The abbreviation PMT means the cash flows in each period are the same amount. Here are some timeline examples. The upper one shows a lump sum, a single amount, due as income, positive cash flow in 2 years. The lower line shows an ordinary annuity with a $100 income every year for 3 years. We'll be working more with uneven cash flow streams like this one, where the cash flows in the different periods are not the same. With uneven cash flows, drawing a timeline and placing the cash flows can be very helpful. Think back to Unit A3, TI Business Analyst 2 Plus Basics. TVM is where you begin to really need your financial calculator and Excel, so let's review the calculator basics a bit. This chapter primarily uses the TVM keys, or the gray keys in the highlighted row. Remember, either the present value or the future value must be negative. You can't have income now and have income in the future. Also recall that interest rates are entered as whole numbers, so 5% is entered as a 5. Data entered in calculator registers stays unless overlaid or cleared, so it's safest to clear registers before starting a calculation. To clear the TVM keys, press the second key and clear TVM. Or, since there's 5 keys, simply put a value in 4 of the keys and solve for the 5th one. Also recall, you should set your calculator to default to 4 decimal places. If you've not already done so, make that change now. Press second, format, 4, enter, second, quit. We'll be working quite a bit with the calculator, but we'll cover the associated Excel functions as well. For each gray key, each TVM key, there's an Excel function. You don't need to remember the exact name of the function nor the order of the parameters. Click on the FX icon and select the appropriate function, and a window will appear with blanks for the needed parameters. We'll begin our study of TVM with future value, since it's the one that's more comfortable. This is the basic future value formula. Future value at a point in the future is the present value times 1 plus the interest rate, quantity raised to the number of periods in the future. In a formula or in Excel, the interest rate is a decimal. If you remember the old future value tables, the values in those tables are the 1 plus I raised to the n power. In your calculator, you can compute 1 plus I raised to the n using the y to the x key. So to compute 1 plus 5% raised to the 3rd power, enter 1.05 y to the x 3 equals. What's the future value of $100 invested at 4% for 3 years? The timeline shows the values and what we're solving for. We can find this future value in several ways. We can do it step by step manually. We can use the financial calculator. We can use Excel. And we're going to look at all three. Taking a step-by-step approach, in year one, the $100 earns 4%, so now you have 104. In year two, the 104 at 4% earns 416, so now you have 108.16. After 3 years, the 108.16 at 4% earns 433, so you end up with 112.49. The general case right there, the present value of 100 times 1 plus the interest rate raised to the power. Solving the problem in the TI Business Analyst 2. N is 3, IY is 4. Present value is a negative 100. It's an outflow. You've invested it. Payment is 0. Compute future value. The associated Excel function is shown at the bottom. Consider the future value formula. For a given interest rate, the longer the period, the higher the future value. Meaning, the longer you leave your money invested, the more you have. As N increases, future value increases. So the relationship between N and future value is direct. One goes up, the other goes up. For a given time period, N, the higher the interest rate, the greater the future value. Meaning, the higher the interest rates you earn, the more money you have in the future. These relationships are direct as well. Now let's turn to present value. If finding a future value is compounding, finding a present value is called discounting. Present value discounts future values to times 0 now. Finding a future value answers the question, how much do I have to invest today to have some specific amount in the future? What is the current value of an amount to be received in the future? Why is a present value worth less today than its face value? 2 reasons. Opportunity cost. If I had the money today, I could invest it and I'd have more than the face value in the future. The further out in the future I'm going to get it, the more I could have earned. Risk and uncertainty. Bird in the hand is true. Money in my hand is certain. Money promised in the future is uncertain. The more uncertain, the more risk. Thus, it's worth less today. The discount rate used to calculate present value is a function of opportunity cost and risk. To find the present value equation, start with the future value formula and just turn it around and solve for PV. This is the basic discounting formula, the opposite of compounding. With compounding, future value is greater than present value. With discounting, present value is less than future value because you're dividing the future value by 1 plus the interest rate raised to the power of the number of periods. Here's a present value example. What's the present value of $100 to be received in 3 years if the discount rate is 4%? Finding a present value is discounting, the opposite of compounding. The timeline describes the problem. Using the formula, present value is the future value divided by 1 plus the interest rate raised to the 3rd power. You can solve this in the calculator by entering 1.04 y to the x 3 equals, flip it over, 1 over x times 100. In your calculator, using the same technique as we used for future value, enter 4 values and solve for the 5th. N is 3, IY is 4, payment is 0, future value is 100. It's a positive, it's an inflow. Compute present value, and the comparable Excel function is shown at the bottom. Looking at the present value equation, for a given interest rate, the longer the period, the lower the present value, meaning the greater N, the larger the denominator, the smaller the result. The further in the future a cash flow will be received, the less it's worth today. So the relationship between present value and N is indirect. As one increases, the other decreases. For a given time period, the higher the interest rate, the lower the present value. Meaning, the greater the interest rate, the larger the denominator, the smaller the result. The higher interest rate reflects greater opportunity cost and or higher risk about actually receiving the cash flow in the future, making it worth less today. Again, the relationship between present value and I is indirect. Here's a refresher in the basic PV equation. It has 4 parts. If you know any 3 of them, plus a 0 per payment, you can solve for the 4th. Do not forget the sign convention. Inflows to you are positive. Outflows from you are negative. This video tutorial is posted in Blackboard, and I recommend you go through it. If we can solve for PV or FV, we can solve for any of the other components as well. To solve for I, you just solve the equation for I. To solve this in the TI Business Analyst 2, you can use both the y to the x and the 1 over x keys. Solving for I in the calculator is much easier. As we did with present value and future value, just enter 4 values and solve for I. Example, what's the annual interest rate that would cause $100 to grow to $119.10 in 3 years? N is 3, present value is minus 100, payment is 0, future value is $119.10, compute IY, 6 years. Solving for N follows the same pattern. We can solve the basic PV equation, but that gets a bit complicated. But you can solve this in your calculator using the LN key, but using the TVM keys is much easier. So here's our example. If sales grow at 10% a year, how long before sales double? You don't need to know what sales are. IY is 10, let present value be negative 1, payment is 0, future value is 2. They've doubled. Compute N, 7.3 years. Well, I certainly expect you'll use either a financial calculator or Excel to solve quantitative problems. This tutorial shows you how to solve TVM problems without using the TVM keys, not really by hand, but using other features of the calculator. The TVM by hand tutorial video is posted with this lesson, and I strongly recommend you watch it. Besides showing alternate ways to solve TVM problems, it'll acquaint you with some of the useful keys and functions of the TI Business Analyst 2. This ends the first part of our 3-part coverage of Chapter 5.